we have learned in the previous section. Okay, so in the previous section, we learned about the definite integrations. All right, so what is definite integration? The definite integration is actually the integration with numbers here. All right, we call this the lower limit and upper limit. So these are the numbers to be substituted into the function to be substituted into the antiderivative. Okay, so after we integrate the fx, we will get the antiderivative. So these two numbers, a and b, upper limit and lower limit, they are actually to be substituted. Right, we are going to substitute them into the antiderivative here. All right, and we subtract. Okay, so this process involved number is called definite integration. And the answer we get here actually represent, okay, what is this? Do you still remember? They are?
Area.
Okay, good. All right, so the definite integration, after we integrate, we substitute the value and subtract. All right, the answer we get, the result we get is the area. Okay, now, okay, so it actually means that when we integrate, we are actually finding the area of fx from a to b. Okay, so when we integrate, the definite integrations is the area below the graph fx from a to b. Okay, so we also we have discussed some of the example. All right, for example, we have discussed this triangle. Okay, so we verify with the formula. So the answer is the same. Okay, so we integrate this, the function 20 minus 4x from 0 to 5. Okay, so we have another example. All right, we integrate this function y equals to x, right, this function from 1 to 3, okay, from 1 to 3, and we can actually find the area is 4 units square, and we verify with the formula. Okay, so this shows that the integrations can be this method is working to find the area. Okay, so also we have discussed one example on the irregular shape. Okay, so we find the area of A and we find the area of B. All right, and we actually sum them. Okay, now there is one unique part on area of B. Okay, do you remember what is this? There's one unique part about area of B. Can you remember what is this? The area you get for B is?
Negative.
Okay, good. All right, the area for B is negative. What is the reason?
The area is under the x-axis.
Okay, thank you very much. Right, so yes, the area is under the x-axis. Therefore, all right, the area is a negative. All right, so now when we look for the area of region B, now we do not write the B first. We will integrate first, and we get a negative number. All right, then we say the area of B is 3/4. We will actually take away the negative, right? Because the negative is showing us the direction. The direction is actually under the graph. Okay, so but the area cannot be negative, so we are going to take the positive only. And finally, right, to find the area of the whole region, the total area, we are going to take the positive region B plus the positive of region A, and we get the answer. Okay, so this is where we stop on Monday. Okay, now next in today's discussion, we are going to learn more about the definite integrations. We are going to learn how to find the area between two curves. Okay, so in the following discussion, this is our objective. We want to find out how to find the area between two curves. Okay, now as you can see in the diagram here, we have two curves here. One is the fx and the other one is gx, right? We have two curves. So we want to find the area between two curves. So this area here, it is irregular, right? Means that it's not like square or triangle, but it's irregular. Okay, now how do we find the area here? Okay, so this is what we do, right? We take the line, we take the upper line. This is the upper line, right? It means that the line here, this is the upper line, all right, minus the lower line. Okay, this gx is the lower function. So we are going to subtract these two functions, all right? The upper line subtract the lower line. Then we integrate again from a to b. All right, so these two values here, a to b, is actually from a to b. Okay, any questions here? So this is the theory, the theory. So we are going to integrate from upper, okay, using the upper line, subtract the lower line. Okay, now let's see some example here. Okay, now refer to the diagram here. Okay, which one is the upper line? And which one is the lower line? Okay, which one is the upper line? Which one is the lower line? Actually, it depends on the region, right? Depends on the region. Now, let's consider region 1. Okay, R1, the region 1. So this line is the upper line. So we have x cubed minus 3x plus 3. This is the upper line. And how about the lower line here? The lower line is x plus 3. Okay. Therefore, to find the area of region 1, we are going to take the upper line, which is this one, upper line, minus the lower line. So minus this one, lower line. Okay, so we have x plus 3 here. And from what point to what point? So we are going to start from this point. All right, so for this point, the x is -2. So the -2 is here, from -2 to this point, which is 0. Right. Now, any question for region 1? Okay. Do you have any question for region 1? Right. Now, after that, we are going to take the x cubed minus, okay, we're going to take the x cubed minus here. All right, so we get x cubed, -3x minus x, -4x. And 3 minus 3 is 0. So after simplified, we have x cubed minus 4x. So we integrate from here. Okay, so what is the answer when we integrate here? Okay, can we have Ziwei? Now Ziwei? Can you help us to integrate here? Ziwei, can you hear me? Lao Ziwei, can you hear me? Okay, Hock Sing.
Yes, sir.
Okay, can you help me to integrate here? When we integrate, what happened to the power? What's the power?
I have no idea.
Okay, what happened to the power? We have been talking about for up here. Plus?
Plus 1.
Okay. Okay, so we have right 4. Then
Divide by 4.
Oh, yeah. So that 4x.
1 plus 1.
Right. Idea. Plus 1 is 3 then.
Divide by 2.
Okay, so then we put 2. Okay, thank you. All right, so after that, we actually simplify. Got a 2 here. All right, so we substitute 0. Okay, after this, we substitute 0. Okay, let's forget about the answer first. Huh? Substitute 0. Okay, substitute 0 here as well. Minus, substitute negative 2 here. Substitute negative 2 here. All right, so then use the calculator to solve this one. We will get the answer is 4 units square. Okay, any questions here? Okay, now as a conclusion for this R1, now the region R1 is here, so we are going to take the upper line, okay, minus the lower line. Okay, so then from this point, negative 2, all the way to 0. Right, so then we integrate and we substitute the value to subtract. We get the region, the area for R1.